Sir, good afternoon. Good afternoon, sir. Nice, sir, nice. So, sir, why is it not audible?
Yes, sir. Yes, sir.
Fine, sir,
Good
perfectly
afternoon,
audible.
sir.
Good afternoon, sir. Good afternoon.
Yes, sir. Shall we start, sir?
Please, sir, please go ahead, sir. Shall we share the desktop?
Yes, sir.
Fine, sir.
Good afternoon, participants. The next session is Introduction to WSN Application Development. Today we have speaker Dr. R. Kumar, Professor HOD E&I Department from NIT Nagaland. Dr. R. Kumar has completed his PhD from National Institute of Technology, Trichy. His area of interest is expertise in wireless sensor network, WBAN, embedded systems design, sensors and actuators, instrumentation system design, MEMS, process control, control of smart structures, intelligent systems, Linux programming, and device drives, etc. Professor has published more than 80 papers in national and international journals as well as in conferences. He has served different roles like lecturer, senior lecturer, consultant in Wipro Technologies, CDC, Tamil Nadu, India, senior consultant in Wipro Technologies, CDC, Tamil Nadu, India. Currently, he is professor and Dean Academics in National Institute of Technology, Nagaland. Over to speaker.
Thank you, sir.
Welcome, sir. Welcome, sir.
Please, sir. Could you please give the sharing option, sir? I'll go ahead.
Yes, sir. You can share the screen, sir. There is option called present now, sir.
Yeah. Present now.
Entire screen or the application?
Yes, sir. Entire screen share.
Yeah. I'm coming, sir. Coming.
Minimize.
Are you able to see the PPT, sir?
Yes, sir. Yes, sir.
Shall we go ahead, sir?
Yes, sir.
Fine, sir. Few seconds. Good afternoon. Good afternoon to all. I welcome IT Trichy Director, Coordinator Dr. G. Sitaraman, Dr. Dhanalakshmi, staff and students for the ATAL program. Here the topic is Introduction to Wireless Sensor Networks Based Application Development. IEEE 802.15.4 or ZigBee. It's nothing but our standard and the commercial name is ZigBee. The main objective is to introduce WSN based application development. Like I'm planning to share the overview of WSN, and then I'm planning to take one base architecture for the application development. I'm just planning to share some application related development also. At the end, some application information, what we have done from the Wipro Technologies. So the agenda, wireless sensor networks overview, the concepts related, or the kit content. It is nothing but our it's like a test bench. People will say,
Professor, sorry to interrupt.
please, sir.
Can you please go for a slideshow, sir?
Full screen, yeah.
Full screen. Full screen.
Yeah, are you able to see, sir?
Yes, sir. Yes, sir. Thank
Fine.
you. Thank you.
No problem. Please update on the information also. Fine, perfectly all right. So I'm also just 1 second. Yeah. Team, are you able to hear me? Just anyone, if you're updating, it will be good. I'm just sharing the full screen. Sir, are you able to hear me? Just anyone, if you're updating the chat, or maybe. Fine, now, sir?
Yes, sir.
Fine, fine. So the agenda is nothing but wireless sensor networks overview and hardware kit contents. It's nothing but I've taken one test bench, not a deployment bench. Test bench is nothing but validation for any, we can use for any type of applications. And software tool chains, what are the way we can use for real time. And then flashing the WSN application to one particular like a 2140 test bench and WSN based application. Like what are the application we developed some application for customer related. That's what it is available. Anyway, I'll share my the application development related. Yeah, wireless sensor networks overview. Just these are all general information on the wireless sensor networks. So wireless sensor networks or WSN is a network of RF transceivers, sensors, and actuators. Distributed wireless sensor network is a collection of embedded sensor devices with networking capabilities. In the other way, WSN is a network of connected devices. Each device has, maybe if you are assuming one particular device, PAN or master device, RF transceiver, for example, each device in the sense, maybe any one device, assume PAN, personal area network coordinator. Each device has RF transceiver, maybe sensor and actuator, and also like additional like other peripheral supported facilities. Similarly, each different devices configure to fancy personal area network coordinator or master device, router and end devices with ZigBee or without ZigBee suite. So we can say the overall each device may be with or without ZigBee suite. That's what it is available. What do you want ZigBee suite is nothing but network capabilities. So if you
Excuse
want to
me, sir.
uh,
Screen is not visible, sir. PPT.
PPT not visible.
Yes, sir.
One second. Yeah, now it's okay.
Yeah, fine, sir.
Fine, sir. So once again, I'm just wireless sensor networks is like the common name. Wireless sensor networks or WSN is a network of RF transceivers, sensors, and actuators. Or another way, distributed wireless sensor networks is a collection of embedded sensor devices with the networking capabilities. That is very important. The last statement, networking capability is very important. WSN is a network like a network of connected devices. Each device, maybe I can take any device from the WSN, maybe PAN-C, has RF transceiver, sensor, and actuator. That is one option. Similarly, each different devices, maybe a router or maybe end devices many or together, no. So configure to PAN-C or master, router, and end devices with ZigBee or without ZigBee. What do you want? ZigBee is nothing but if you want to communicate, you can use RF transceivers. That's a base RF network communication. If you want ZigBee, additionally network capabilities will be there, like what type of network capability is required, and whether it is acknowledgement is required, reliable communication, whether it is required for like something broadcasting or unicasting, all the support will be available with Zigbee suite. Base like platform is RF. Additionally, we are adding with Zigbee suite. Whether it is Zigbee suite is required or not, your recommendation only. So we can say that PAN-C or MOS is usually only one device in a particular PAN network or maybe cluster. PAN-C or master device, overall the particular PAN network, or maybe we can say cluster, only one device. But router and end devices may be more than one. We can say like can be many based on the application. That's what it is available. So for example, I'm just working to a wireless system for level control with sensor, valve and display. Just one simple layman example. Here our aim is to maintain the level of the system. Maybe the bottom valve, it is open. Some percentage of opening is at the bottom valve. Assume it is pumping, the motor is pumping the liquid to the top tank through the control valve. So the sensor node is connected with one particular maybe level sensor, and the valve node is connected with the assume that the smart valve, then display unit connected with the display, maybe a PAN-C or maybe a master device connected with the laptop or maybe other display unit. Here, see if the level more than send point, automatically the valve will be closed. Here it is through wireless. Similarly, the level is less than set point, it will open the valve. That's a base concept. In a conventional control, we need bunch of cables or wires from field to control room and back to the field. But in the wireless, in the case of wireless sensor networks or other wireless standard, we don't want bunch of cables from field to control room and back. Even a small one control loop, we need 2-wire transmission or 4-wire transmission options are available. So that's what is it, not only control, medical or other like applications. That is the base platform, it is available. I'm just moving to the next one. Wireless sensor networks. In a wireless sensor network, sensors are employed at different physical locations and they communicate via wireless medium. One wireless, at least WSN, wireless sensor networks, and this is one standard of wireless. I'll come to the like at least or other standard also. So wireless sensor network consists of, for example, if you are talking about one particular wireless device, maybe it has at least RF transmitter and receiver. Maybe based on the application, sensor will be there or actuator. More than one sensor and actuators are possible. Or other way we can say sensors and actuators, RF transceiver, machine controllers and microcontrollers. Machine controllers in the form of algorithms only, and microcontroller and interface devices for the sensors and the actuators. So this is nothing but we can recommend as a one particular device. Maybe a PAN-C or router or maybe end device. That's a recommendation. Maybe at least for wireless communication, we need minimum 2 devices to communicate from one to another one. That's what it is available. Then you are targeting maybe network related. We have to recommend some network related topologies. Coming to the sensor node, like hardware blocks. So when you are talking about this hardware, this is one particular or single hardware related just line diagram. See, sensor, here it is only one sensor. Sensor is integrated with the processor through ADC or direct digital integration to the processor. The direct digital integration in the sense, mostly I2C is one important option is available, most of the integration. It's a direct digital integration to the processor. Without, maybe if you are using ADCs or maybe the direct analog interfaces, we need at least one amplifier, maybe the mapping the signal, filters, and maybe the ADC. ADC may be 8-bit or 10-bit or 16-bit resolution. So in the case of direct digital integration, we don't want any amplification, filters, and analog to digital conversion. Direct digital integration to the processor without loss. That's what it is available. Most of the cases now we are using direct digital integration. And see, whatever the information you are transmitting from the sensor to the another node through transceiver, then it reaches to the opposite node with one wireless standard, in this case WSN. Similarly, in the opposite node transmits some signal in the receiver. This is transceiver receiving the signal to the processor. Then it reaches to the actuator through DAC or maybe the direct digital integration, maybe I2C, inter-integrated circuit. And these are all nothing but power unit and power generator facilities are available. Yeah, I'm just moving to this is one particular node. Like maybe I'm thinking that one sensor and actuator, maybe if you want, you can connect more than one sensor and more than one actuator also possible. Time sharing, maybe scheduling concepts can be used in the development. Yeah, I'm just moving to the next, wireless sensor networks. WSN, like a characteristics, large number of devices can be connected. Usually, one PAN ID will be there. Number of devices, maybe 2 power 16 minus 2. Usually that 2 minus 2 similar to network support cannot be used. And this number of devices can be used one particular PAN network, or we can say cluster. So may interact with other devices in the same network, or maybe from the same network, any one device can communicate. Usually PAN can communicate to other PAN of next cluster. That's the specialty it is available. Sensor block, it's nothing but we can say sensor, processing unit, RF transceiver, and user interface device, nothing but the single hardware. Then application, the sense, like a lot of n number of applications, there is no limit. Based on your vision only, your application will be considered. Environment monitoring is one application, home appliances, mission control, and other applications. N number of applications are available. Even industry also, there's n number of cases. I'll show one or two simple test bench application, not deployment. Deployment, I cannot share the deployment because that is commercial. Yeah, I'm just coming to them. This is nothing but ZigBee or IEEE 802.15.4. This is nothing but, first, ZigBee is nothing but commercial name for wireless sensor network. And the standard is IEEE 802.15.4. Even I can say one simple, I'm taking one, maybe a paint, just one paint, 1 second. Maybe the wireless standard related, no, we'll see whether it is, yeah, I'm just taking, yeah. It's fine. So I'm just taking for example, one particular standard PAN or IEEE PAN, personal area network. This is one particular PAN network. Here we can say, are you able to see the paint information? Anyone, if you are updating, it will be good. PAN, I'm just typing PAN, and IEEE standard maybe IEEE 802.15.4. That is the standard for one particular wireless standard. Maybe we can say this one is nothing but yeah. Another we can say WSN is a normal application. WSN team, are you able to see the information? Anyone, if you are updating, it will be good. Team, are you able to hear me? Sir, are you able to hear me?
Yes, sir.
Yeah, another one similarly, I'm just taking another standard. Here it is 15.4 is the wireless standard, nothing but PAN, personal area network. Maybe the example is wireless sensor networks. Similarly, I'm just taking another option, maybe wireless LAN, WLAN. This is another standard, WLAN. Here IEEE standard, maybe we can say 802.802.11. It is nothing but Wi-Fi. It is Wi-Fi standard. Similarly, one more important standard we are using, WiMAX. Maybe we can take WMAN related, and then the standard is 16. So the standard will be 16, and see the condition WiMAX. Example is WiMAX. So see, what do you want to relate this WiMAX? Yeah. So the first one, nothing but WSN, nothing but IEEE standard 15.4 is PAN network, but WSN is example. Similarly, 11 is nothing but Wi-Fi, wireless LAN, and 16 is nothing but wireless metropolitan area network. Example is WiMAX. So if you are, for example, if you are planning to communicate in a building, multiple floors or nearby building, not more than 100 meters, but the data also number of bytes, not 64 kbps in the form of stream of bytes or videos or maybe streaming of data. But in the case of Wi-Fi, we can use streaming of data. Other supports are possible. But in the case of Wi-Fi, see, if you want to communicate in a like a triple IT, like a Srirangam Trichy campus, you can use this type of cases more than the building or nearby 100 meters. And third one is WiMAX, maybe part of city, Trichy city, part of the cases we can communicate. That's what the transceiver capacity can be designated to communicate. So these are all the options that is available. So I'm just coming. Are you able to see the PPTs? Or anyone, if you are updating sometime, no, it will not be visible. Yeah, the short range, low data rate wireless standard for communication between machines in networks. Short range is nothing but not more than 100 meters. That's the visible distance usually. So if it is more than 100 meters between two nodes, then one router will come. And also number of bytes, not for stream of bytes, stream of like a 64 kbps, etc., image or maybe other streaming of data is not possible. Number of bytes only. These are the cases or limitations. And self-organizing and self-healing and ad hoc network. It is nothing but your, for example, 100 meters radius, number of nodes are available. One node is moving away from the network or maybe from the cluster, automatically it will be discarded. Once again, if it is receiving to the inside the radius, automatically the PAN device will assign the addresses. So these are all the supporting facilities by its default. ZigBee or standard will support, and also networking other supports, reliable communication. I'm sending the message whether the reply is available, acknowledgement is available, and also like a broadcast support, unicast related, and also other network related functionalities will be available with the standards in the form of ZigBee. So these are all the important information, and just moving to the futures are no wires. That is a important fundamental information. People will not be using wires. Low power consumption. It doesn't take much power. Even the processor, usually 3.3 voltages or maybe 1.8 voltage machines are available. Mesh network. Not only mesh, you can use any topology for network, similar to network communication. And over the air programming is nothing but, suppose already deployed, it is working in the field with the application. If you want to change one device, yeah, you can program from the master device, any one general machine, then program to the particular device or node 1 through wireless. Over the air programming, that's what the option is available. And supports large network orders, nothing but 60, like 2 power 16, 64K, it is supported. That number of devices can be used in one particular cluster or maybe the PAN network. Flexible protocol design, you can exclude the protocol related encapsulation. The facilities are available in this particular standard also. Then coming to the stack reference model, just I'm coming to the stack reference related, nothing but these are all base comparison only. I'm assuming this portion is related to your TCP IP suite. The right side portion is related to TCP IP suite. The MAC, nothing but it's your very clear hardware address, 48-bit in the case of, these are all nothing but TCP IP suite. MAC is nothing but 48-bit address, very, very clear, 6 bytes. And IP is nothing but 4 bytes. And 32-bit information, and additionally one more information it's available at the transport layer level, port number, 2 bytes information based on your application. So these are all the information, nothing but MAC address, IP address, and port number will be considered for TCP based communication. Whether it is TCP or UDP will be considered. TCP in the sense connection oriented, but UDP connectionless. Maybe I'm sending the information, I'm not bothering whether it's reaching or not. That's what the UDP scenario is available. When you're coming to our ZigBee suite, see physical related MAC and network ID, and then application will be available. If you want to add ZigBee suite, that is additional like a facility. Without ZigBee also can be used. That's a specialty. In general, device address and network common ID will be there for all the devices in a particular cluster or particular common PAN network. Yeah, and just moving to the physical layer features here, when you are coming to see the MAC and physical can be recommended as IEEE 802.15.4. The next layer, nothing but network layer, ZigBee Alliance platform. It is nothing but network facilities, whether acknowledgement is available or otherwise end-to-end communication is supported. and other facilities, topology related, etc., etc. All the information, maybe all the other network functionalities will be added with ZigBee platform only. So if you want to use the base 802.15.4, one option, but technically the base standard is 15.4 only. But additionally, ZigBee suite is available or not, your recommendation. If you want network facilities, all the additional facilities, then suite also will be additionally taken. And operates in two separate frequency ranges. One is low frequency physical layer, 868 MHz European, and 915 MHz US and Australia. The second one is high frequency ranges, nothing but 2.4 gigahertz, worldwide. Most of the people will be using the 2.4 gigahertz only. That's what it is available. I'm just moving to the additional features are responsible for providing reliable communication between a node and its immediate neighbors. So it is nothing but reliable communication related to, so in the network related, TCP is there, no? Reliable. I'm sending message, acknowledgement will be there. Similarly, here also, acknowledgement by default, the facility is available in the case of ZigBee. Avoid collision, nothing but if you want additionally, the carrier sends that collision avoidance, the additional facilities, CSMS, CD related facilities also, you can incorporate that facilities are available. And the last one is very, very important. This is nothing but assembling and decompose, nothing but fragmentation and reassembling. Fragmentation and reassembling is available in TCP also. It's nothing but if I can say fragmentation reassembly is possible in a WSN similar to TCP IP suite only if a packet is reaching to nearby router and if the bandwidth is not sufficient for the message, then it will be fragmented into small packets. These fragmented packets will be reassembled in the next router or in the destination node or host. Similar way, it is possible in WSN also. That's what the facilities. Maybe if you want, I can share a small information. This is nothing but yeah. Here I can maybe consider as network topology. Yeah. This is one network. Maybe I'm assuming that this is a network, and maybe I'm just thinking this is a router or gateway. So I'm thinking that or gateway. This is router / gateway. The message is reaching here. The message, for example, this is the actual message. It is coming here. Maybe I'm just taking the message is coming to the router. So what happened? No, the bandwidth is not sufficient. It will be fragmented into small packets. Then it will be three, for example, I'm fragmented into 3 packets. So these 3 packets will be treated as a individual packet, but it has some property. For example, this is sorry, I'm not able to, yeah, I'm drawing the bottom. See, you assume this is the original packet. So this is one partition, second partition. Maybe this is the original machine, the form big size. So this is a common ID will be the, even if it is fragmented into 3, this is one portion, maybe second, and similarly third also available. These 3 cases, see the condition offset will be common ID for the fragmented packet, and offset will be for the first one is 0, maybe second one maybe 49. I'm assuming 49. Second one maybe something like 154. Some number I'm just taking based on your ID, common ID, and the offset for fragmentation. It will be identified with the ID, and the offset will be considered for fitting into the original message, either in the next router or maybe the destination node. That's a specialty is available. The complete support also available in the this type of WSN also. That's the last statement. Fragmentation and reassembling also supported in the case of WSN with the ZigBee suite. Yeah, and just coming to the topology. So network topology is like a star. These are all normal topologies only. Star topology, cluster tree topology. Another one is mesh topology. Usually people will be taking mesh topology. Nothing but if you want to communicate from this node to another node, you can forward the information to one particular path. If it is not if it is a congestion or not able to transmit, then you can take alternate path in this type of mesh topology. That's a specialty. And When you're coming to your fancy master and router, fancy router and end devices, see the condition on the left side. Fancy or master is usually only one device in a PAN network. But router and end devices can be many. That's a specialty. So base device will be only one. Router is based on if the distance between two nodes are more than 100 meters, one router should be there. Based on your distance, you can accommodate more number of routers. End devices based on your application, what type of application, that's what it is available. Usually, more number of end devices will be there, and more than one router will be there. Usually, only one PAN device. That's a base. Yeah, coming to the ZigBee device model. Yeah, ZigBee network includes the following device types: PAN coordinators, routers, and devices. The PAN coordinator is nothing but it is treated as a master device. So devices starts and controls the network. Even n number of devices are available, maybe a router, n devices, or maybe the including PAN. Whatever the message, maybe n device 1 and 2 communicating, that frame also will be captured by PAN coordinator. Stores the information about the network. Whatever the message it does, any one like 1 to 1 or 1 to something router, n to a router, that information also will be captured and recorded. The full function device, FFD, people will say FFD, full function device, can have router and end device children. Nothing but when you're looking from the PAN coordinator, maybe the router and end devices are next level devices. That's what it is treated. And mains forward in the sense, always on. You cannot operate as an on-off mode. It should be always on because it is a master device. If it is an end device, you can make as a on for some period, then you can switch off to off period, maybe some period. That's what it is. Then coming to the router, extends network coverage area. Usually the distance between two nodes are more than 100 meters. By default, one router will be there. Otherwise, router is not required. Dynamically routes around obstacles, similar to ordinary other wireless communication only, provides backup routes in case of network congestion or device failure. Suppose one device fails or network maybe congestion or maybe the other traffic, then automatically take alternate route to reach the destination. That's a specialty using this type of routers, and similar to normal communication also. Can connect to the coordinator and other routers also, can have router and end device children. Nothing but from this device, maybe other routers and end device will be treated as the next level or children's. And coming to the end device, devices capable of transmitting and receiving messages of sensors and actuators. Basically, end device is nothing but you can connect more than one sensors or actuators in a device. So in this case, whatever the sensor information you are transmitting, you can transmit to the opposite node through the wireless this standard. And similarly, whatever the information you are receiving, you can receive and display to the actuator. This will not perform any routing operation. End device will not perform because there is no facilities available in the end device. Must be connected to either a coordinator or a router. Nothing but next higher level router will be supported. Next level is by default hierarchy wise fancy only the more lost. Does not support do not support child devices. From this device, there is no a concept of next lower level device. All are the same end device only. That's what the generally battery powered. But if you want on off itself. Yeah, coming to this is one I was there in Wipro based out of Chennai location. I was there for some wireless related complete end-to-end life cycle also. This is one lab, WSN lab, wireless lab. Similarly, other Wi-Fi, WiMAX labs also available in Chennai location. I was there part of one. I was there 10 years, but majority cases embedded related application only and wireless related applications. See, this is in the right side, you can see this is one wireless node test bench, very important, not deployment. Deployment will be small device. So anyway, I don't want to I will not be in the position to share as a commercial devices. Maybe these are all test bench, validation bench. Right side, maybe this is one node. The number of nodes are available here. Similarly, left side also number of nodes are available. These are all one WSN standards. All are WSN standards only with the transceiver, with this transceiver. So here the transceiver is for WSN standard. So this particular, maybe I'm assuming this particular node, you can configure it to fancy. Similarly, the next device you can configure to maybe router 1. Maybe this device you can configure to router 2. Similarly, this device you can configure to end device 1. Similarly, this one is end device 2. And one more point, usually our PAN-C device or master device, I told this can be configured as a master device, usually the PAN-C will be this type of dongles only. Even end device also with connected capacity, it will be like small size device, not exactly the size, maybe similar to this model only, but this one is miniature, the PAN-C. The PAN-C usually will be this is sniffers. People will say technically sniffers, but this will be the master device. Maybe the same performance, you can use this type of devices also, test bench devices also. That is very important information. I'm planning to share some information related to this particular device. How do you do from common platform? What are the important constraints we are taking? That's what I'm just sharing. Otherwise, we can use simulators also to test the performance. This is a real device. So because the industry related, we have to use, we can check with the simulation. Finally, we have to go ahead with the real execution one. So we have to complete the end-to-end complete project on the particular band of period. Otherwise, the complete activities will be stopped. That's a specialty in the case of industry-related activities. Yeah, I'm just moving to the next one. Yeah, this is open source information only. Suppose the switch, in this case, the layman example wise, switch is connected with one node and the lamp is connected with another node. So if you are operating switch in one node, then it will activate lamp in another node. So the message or information will reach to the destination through the different nodes and reaches to the destination. Suppose this particular node or maybe 2-3 nodes are not working, then what happens? It will reach to the destination through alternate path. The alternate path support also available with ZigBee. So I'm just moving to the next. See the condition. This is alternative. If the other few nodes are not working, then alternate path will be taken. Then coming to the network functionality. So here I would like to add self-organizing, see the automatic addressing and adding and removing nodes. It's nothing but I'm just taking one same like a paint related. See the condition. I'm just taking the new one. See something related to yeah, this is a complete node. You assume that's complete. So here I'm taking, this is the one node, maybe small nodes. This is another node. Different nodes are available. Sorry. Yeah, different nodes are available. See the scenarios. This is the complete cluster or maybe the PAN. So one device is out. Maybe it is there. Something it is coming out here. For example, this is the one node and it is coming out. Maybe I'm assuming like this. So in this case, this device is going out of the boundary. Nothing but I'm thinking this the radius, total radius is 100 meters. Maximum of 100 meters only. Total radius distance is 100 meters in general. Suppose if it is reaching, even Chipcon or Nordic will support for 100 meters. Other devices will not support without noise. So even industry people will select a Chipcon devices for transmission without noise. So that this device is out, in the sense, automatically this will be discarded from the network. Suppose once again, if the device is coming in, then automatically this will be considered assigned with the hardware address and also the PAN ID. That's common PAN only. Common PAN ID, individual node address will be different. That's what it is available. So I'm just coming to the, yeah. Now see the condition. Here we have PAN device, router 1, router 2, and end device 1 and 2. So I'm planning to transmit from E1 to E2. How it does the operation? Just to see the condition, like first request, route request, route reply. The route request and reply similar to ARP in the TCP/IP communication. ARP is nothing but if I'm familiar with the IP address of opposite machine in TCP. So see the condition. I'm just moving to the TCP. In TCP, IP communication, ARP communication. If I'm familiar with the IP address of destination machine, I can transmit broadcast information packets to the opposite machine, especially to the particular network ID, net ID areas. I'm just planning to broadcast into particular IP address. It will reach the message to the particular net ID area. Then it will broadcast. For example, I'm planning to send the broadcast message from here to your IIIT PC lab. Then what happens? It will reach to the router then or the particular router. it will broadcast in that particular area all the machines. So like initially broadcast, the corresponding IP address machine will reply with the MAC address. Then both the MAC address and IP address available, port number is not compulsory, we can do the communication. That's what. Similarly here also, see the condition, route request is broadcast, reply will be unicast, similar to R, but similar to R, very important. Then you can do data transmission, acknowledgement is similar to TCP acknowledgement. That's what it is available. See, that is like in the case of data, and maybe this is acknowledgement. Each and every device, E1, see R1 does broadcast, but E1 also does broadcast, I didn't mention. But basically broadcast will be done. Then in this case, see broadcast is done, nearby machine will reply, which one is near. Once again PAN or router 2 will communicate, or router reply will be done, then data will be sent, acknowledgement will be there. Similarly, it reach one by one, then finally it reaches to the E2 based on shortest link. So it has like a procedure also in the network topology related. These are all the supports available in the fundamental functionalities of ZigBee suite. Yeah, I'm just moving to the concept wise. Yeah. So finally, it is coming to the end location, the form of data and acknowledgement. That's what it is available. Yeah. Then I'm just moving to the ZigBee Alliance platform. ZigBee Alliance, see the condition. ZigBee Alliance is nothing but Ember, Freescale, Honeywell, and these are all Siemens and Texas Instruments. These are all ZigBee Alliance. Nothing but suite recommenders. ZigBee suite recommenders. Even Wipro also application adopters. Wipro also cannot recommend the suite, because whatever the recommendations available, similar to TCP suite, we use the facilities. We can use the ZigBee platform in our hardware related application development. Wipro also not a ZigBee Alliance recommenders, application adapters. I can use this recommended from these people. That's what it is available. ZigBee Alliance. Coming to the application, I think these are all the general like open source application names only, but we can use any type of application like applications, ZigBee applications or WSN applications, or vehicle monitoring, patient monitoring, home appliances, and then seismic detection, then ship monitoring, machine control, and machine control, this is industrial automation or control, and animal monitoring. These are all the general applications, but there is no limit. You can use any type of applications. Nowadays, it is WSN also, like WSN, other wireless standard with the gateway, you can use as a IoT. That's what it is coming to the latest like integration, right? So I'm just WSN based application development. See, when you are coming to the application development, I'm just thinking, see, these are all, just now I'm moving to the overview, then I'm moving to one particular hardware, how we are correlating to the particular like development scenario. Just I'm giving one overview. This is one test bench, not deployment bench. Test bench in the sense, any type of application we can connect. Deployment in the sense, only for that particular application and only for that particular device drivers and device related facilities will be there. Here, I'm assuming like the one particular test benches, multi-purpose interface board, MPIB board is available. Then MCB, like ARM processor one board is available. And then CC2430 ZigBee radio transceiver. This is nothing but ChipCon 2430. ChipCon 40 also available. Other standards are also available. Usually 3040 will be used without noise or noiseless, optimum noise transceivers. This is very standard family of transceivers, will be used most of the industrial applications. ChipCon family, this is ChipCon. Nordic also will be there. If you want low budget, other XB, other RF transceivers are available. Usually these are all recommended without noiseless transmission. That's a specialty. Yeah, I'm just moving to the actual hardware. See, this is the first level. See, just the information. I don't want to enter the internal cases. See, this is the one MPIB board for in the WSN development. Maybe you can use some other hardware also. Just one simple example here, like this is the base MPIB multi-purpose interface board, our own design. Even I was there in the complete design also. MPIB board. In this MPIB board, like see right side ADC connection, ADC 0 and 1. This is general purpose GPIO terminals, and these are all LCD, normal LCD. Even you can connect to the touch screen panels also. Then like one serial port and 4 relays and direct GPIO terminated outputs are available. So coming to the next level, see the GPIO terminal. I'm just thinking this particular here left side ADC 0, ADC 1 is available. Here it is nothing but the switches integrated or connected both the processor with interrupt. Similarly, the second switch also connected with the interrupt. I think you are very clear what is the meaning of interrupt. It's an asynchronous event. If the switch, nothing but this is like a switch in this case, 32-bit processor, almost 32-bit processor, it has two edge enabling, nothing but rising edge, falling edge also will support for interrupt. So usually you can use both the edge enabling or falling or rising edge can be used. You assume that one edge. So rising edge is there. What happens is interrupt signal is there, then automatically the handler corresponding to the like interrupt will be executed. So anyway, assume that switch instead of sensor, this is switch, but it is connected with the like process in the form of integrated with the processor in the form of interrupt. The corresponding signal interrupt in the sense rising or falling or both. Usually any one or both also possible. Some applications rising edge. Then rising edge is there. Automatically the corresponding handler will be executed. Then executed in the sense in this particular case we used for something like transmitting signal to the opposite node with the particular receiver address. That's what it is available. Maybe like see the next level. These are all the opposite machine. You assume that in the other machine it has like maybe the LEDs connection and like a release. Maybe the output voltage from the terminal is usually 3.3 voltage DC. Maybe some processor has 1.8 volt DC also. The 1.8 maybe it is like a LED display option is available here, or otherwise if you want to drive LCD or light 230 voltage or 440 voltage related drives, you can use the relays. So input will be like 0 to 3.3 volt. Output may be on off for AC or drives related signals. So in this case, this is a complete hardware. I'm assuming you are very clear with the complete hardware. See, the MPIB board, I told you the first board is MPIB, multi-purpose interface board. The multi-purpose interface board is nothing but the base board. On top, your ARM processor, this blue color board will be sitting. Why do you want this facility? Because we can use not only this ARM processor, you can use DSP processor or other PowerPC processor, but the base will be common. So base will be common to other interfacing, but the master board maybe in this case ARM processor. Maybe if you want, you can use your DSP or PowerPC or some other processor also. That's the like option it's available. So the base processor is nothing but base board is nothing but MPIB, multi-purpose interface board, the ADC 01 and general purpose, and maybe this is the transceiver area. Transceiver is nothing but CC, Chipcon 2430 or 40, etc. Other versions are available. This is noiseless transceiver and the serial port and other LED terminated, and these are all relays. The top blue color board is nothing but we purchased from outside. The bottom one is our own design, but the top board is standard board from ARM only. So this is the ARM processor, and these are all GPU terminals terminated with LEDs only. Other GPU terminals are available. These are all serial ports, and all these terminals, other GPU terminals terminated to the bottom. So MPIB board 1 and top we can connect to the other boards. In this case, ARM processor is available. This complete unit is treated as a node 1, maybe a fancy or router 1 or router 2. The application you can connect anything. There is no limit. But this is general purpose because you can connect anything. But if you are coming to deployment related final device for one particular application, one particular node, in the sense we have to use this ARM processor and particular serial or USB connector will be there. Maybe one or two other terminal devices will be there, very small devices. You can fuse the application final to the device. That will be the deployment device. In this case, this is test bench. We can use for any type of application, any industrial applications. You can test and validate. Yeah, coming to the next, see, these are all like software platforms, tool chains. Kale microOcean 3 or 4 nowadays open source. This is very, very like 30 days license are available. Even industry people also will check for validation related. Maybe like you can use other softwares also. The Kale microOcean 3 or 4 ID compilers, NXP process are used. Maybe you can use, we used VxWorks, QNX, other commercial OS also for this type of application. If it is time constraints, we have to use commercial OS only. So full-featured source code editor facilities will be available. Project management, maintaining the project, integrated make facilities for assembling, compiling, linking, all the facilities, complete suite. From the complete suite, we can port the fancy master device, or maybe like a router, or maybe end devices. So from the common suite only we are developing the application. Finally, we are designating that HEX file for one router or router 2 or router 3. I think you are getting the point. Common suite is available. From the common suite only, your actual EXE file will be generated for fancy, or EXE file will be generated separately for router 1 or router 2 or router 3. Or maybe a number of end devices separately. HEX file will be generated from the common suite only. But how do you do? That's a general procedure also. Not only one organization, all the organizations, same concept only, because we use it for real-time customer-related application, n number of applications. So coming to the, see the condition. This is like one expectation, switch and lamp application. In this particular case, see the condition to develop a simple switch lamp application based on Zigbee and test. Assume we have fancy, router 1, router 2, and router 3. So see the condition, router 1 has been configured to switch node, and the second one is temperature display node. Similarly, R2, like a smoke display node and temperature sensor node, and R3, smoke detector node and lamp node. So S stands for sensor, A stands for actuator. See the line, there is no meaning of this line. All are wireless communication with the 15.4 only. So see the condition. If you are like a switch, if you are operating switch in this particular node R1, it will activate lamp in another node, provided proper network, what type of topology you are adding in the development, and what type of link address. Where do you want? Suppose R1 to R3. So how it is passing via PAN and R3, and which way it does. These are the cases. Like here, it has different additional parameters. Like R1 has been configured to this one, R2 has been configured to this one, R3 has been configured. But here, the device functionality very important, and what type of topology you are using, and what type of application you are adding in the particular device. These are the cases are available. For example, R1. Like if you are thinking about R1, see the condition switch. Suppose in the final application execution, if you are operating switch in this particular R1, then it should activate lamp in this particular node R3. Similarly, the temperature sensor, if this temperature sensor detects some temperature in R2, that will be displayed in R1, that is temperature display node, this one. Similarly, smoke detector from R3 node, then it will activate a smoke display or siren in the R2. So in this particular like a PAN and router 1, 2, 3, we have some integrated applications. Similarly, any type of application you can configure and do it, but the procedure is same. How do you develop? How do you do that? But if you are familiar with the programming of the application and configuration, same scenario for any type of application. Maybe I am thinking fancy router 1 and 2 with the end device, some 4 or 5 devices. We can configure and do it. That's what it is available. So even standard suites are available for developing the WSN applications. Even industry standard. Even I have one standard suite from Wipro also. But similarly, standard suites are available, provided the person should know, the developer should know the programming some extent, not exactly very high level, reasonably good. So that's very important. Then how do you configure? How do you use? That's a specialty here. Otherwise, you have to go ahead with the simulation. But research papers, we can use simulator only. But real time will take more time. Yeah, coming to the next level, how do you do individual device? For example, R1, how do you configure and use? R2, how do you use? R3, how do you use? That's what I'll give the overview only. Then I'll go to the application. So coming to the first level, I'm just thinking switch S1 on the MPIB, multi-purpose board. Switch is available in R1. You assume that R1. The switch is available here, R1 router, not end device, router. See, the switch has been already discussed. Switch, nothing but the switch integrated with the processor in the form of interrupt. Interrupt is asynchronous operation. If the interrupt comes, nothing but the rising edge is enabled in the sense rising edge signal is coming, immediately it will invoke the handler. In this case, the handler will forward the, like, what are the message we are transmitting to the opposite node. The opposite node also you have to configure internally in the development. And what I to like enable, but primary informations are available. So we'll see how. So in this case, you assume that this switch has been like integrated with the like, processor through interrupt. See the condition, the other end, suppose the information transmitted from one node, that previous node, this is the sender node, the switch node is the sender node, then the receiving node is nothing but this lamp node, nothing but here it is connected with the lamp is nothing but there is no, like the LED also okay, or otherwise we can say we can connect to the real LEDs through relays. In this case, I have just taken one buzzer. So if the information is received from the opposite node to here, it will be received, then it will be like driving the, in this case, assume LED, or otherwise you can drive the facility. If you integrated with the like a light and maybe 230 voltage AC in the thing, directly you can glow the lights. Not only this, even any type of application you can integrate. In this case, simple switch and lamp application, but in the real scenario, we can integrate n number of cases. Yeah, coming to the next level, just to see the condition. Team are able to see, just I'll give the overview, what is there in the complete common development. These are all the real scenario we are using in the development platform. So the configuration to the PAN-C, that is PAN-C is nothing but master device. In the PAN-C, see the condition, like first, this is common suit for any type of device of WSN, maybe WSN, similarly Wi-Fi, WiMAX, all the cases, our common suit is available. So how do you develop that, we should know. That's it. So in this case, PAN-C, see the condition, the device enabling condition, PAN-C from the common development platform, PAN-C is enabled. Router I am not developing. This is for PAN-C development related facilities. So PAN-C I am not using. Router PAN-C I am developing. I am just permitting PAN-C. Router and end device I am disabling. There is no sensor in the PAN-C. Assume that this particular this is like there is no sensor in the PAN-C device. But router 1, router 2, router 3, sensors and actuators are available. Similarly, no, see the condition see here, first PAN-C firmware development, PAN-C has been enabled, router and end device disabled. No sensors in this particular application. And also see the condition, when you are looking from the PAN-C, how many router childs are available? 3. That's what 3 numbers enabled. Maybe if it is 2, you can mention 2 also. Then next portion is the application ID, application device. Meaning is like this is very standard international approaches also. Temperature in the sense more than one temperature device will be there in a particular application. So T will be the common name. T1001 in the sense that is the ID. T next sensor T002, T003. That's what next. Device. The application will be common for applications there you need so directly we can convert. Maybe you can take some minimum like .C supported facilities, then convert it into HEX for this PAN-C device, then download to the hardware. Then it will be ready for the execution. That master device is ready because backend, the complete network topology related, all these things, default facility will be taken from the suit. I'm not editing anything, but include, exclude all the facilities available. I'm just giving overview only. So see the condition, select the PAN device. If you are planning for HEX, PAN-C, router end device, disable. How many child from the PAN-C? 3. Then any other application, nothing. That's what default options are available. HEX will be download to the PAN-C device. That is real device you are downloading. Then coming to the next one, router 1. In the router 1, what are the steps? Similar to the previous, but what are the way? See the condition, like the PAN-C disabled, end device disabled, only router, because there is no end device here. So router 1, now the sensor connected, enabled sensors connected only, yes. Then see the condition, end device, and maximum router childs. Maybe when you're looking from the router, the PAN and router 2, router 3 are available. No, totally 3 childs. So that's what 3 is available. When you're coming to the router 1, what are the devices available? Application ID is common name, switch. Maybe you can say switch lamp or switch application. Then actual devices, switch node, exact device. Then this for switch device .c file also will be available. Similarly, application ID, temperature like a sensor. This is a common name, but device ID will be the exact device related .c file will be there. In this router related, the device related exact .c file also, sensor switch node related .c file will be available, and device related temperature display related .c file will be available. But the application ID is common. Device related .c file is also available, and actuator, this is A stands for actuator related common name, and actuator related display also .c file will be available. Put together, you are converting into HEX. That will be downloaded to another hardware that is designated as a R1 router, and additional facilities, default facilities will be available in the suite. But you can write only the switch related .c file and temperature related .c files. Similarly, router 2, same scenario, only see the condition, all the router related 3 and all the application related here, sensor related, temperature sensor related application, smoke display related .c file will be the converted into your HX file. Similarly, router 3 also, in this case, router 3, see router related and all the sensor related .c files will be integrated and converted into HX. That's a general procedure. Coming to the integration of sensors, no, then after 1 or 2 slides I'll come to the application. So integration of sensors, see, these are all interrupt related. I don't want to enter the programming related. Interrupt related, directly you are taking the switch is connected to the interrupt. Similarly, the if the switch enabled, nothing but the handler will be enabled. Handler is nothing but IR, interrupt handler. Automatically it will transmit the signal to the opposite node. Where do you want to transmit? Then the receiver, the lamp node, no. What is the lamp node? Lamp node, the receiving end. Where do you want to display enabled with the configuration out files? So nothing but maybe port 1, in this case 17th pin number. That's what it is available. This can be done. These are all programming related. I'm just moving. So coming to the ZigBee stack and flashing the WSN application. See what are the way we are using. See the condition. This is a one standard procedure. I think common main .c file will be there. If you want additional .c file like UART.c, ADC.c, GPIO.c, timer.c, like LCD or maybe other .c file, you can take as a HAL, hardware abstraction layer. Nothing but you can take as a separate C also. Totally you can integrate nothing but header file to the main file, and other header files can be separately. You can add as a header file for the particular process. Nothing but whatever the additional devices you can add as a separate file, and main will be there. So main will be the directly you can call, or you can take as a profile. This is support of you type of on low. So the package only. We cannot use open source to download. Sir, are you able to hear me?
Yes, sir. We can hear you, sir.
So are you able to see the last this one, like application slide of flow management, right? Yeah. Just will, yeah. I'm just planning to share some application, then we'll come to the end. Yeah. This is one I was there in one ATL lab, advanced technology lab, across the centers. Here what happened was customer related application will be developed, especially to WSN related few applications we developed in the base location Chennai also. So here one level that is like control related application, the sensor is connected with the node 1. Similarly, left side valve is connected with the node 2. And one more like a master fancy is connected with the display node, fancy or master. So in this case, see the condition, we can connect more than one sensor in a node.
Yes, sir.
Sensor. Yeah, please.
Presentation not visible, sir.
Please come again, sir.
PPT not visible, sir.
Not visible. Oh, up to last slide, it was visible. Sir, up to last slide, it was visible, or now only not visible?
Now only it is not visible, sir.
Okay.
Sir, no screen is visible, sir.
Oh, 1 second, sir. 1 second. Maybe it is coming out. Sir, is it okay now?
Okay, sir.
Sir, here the WSN related, that's what I told. No, I was there in one wireless related development. One application is a WSN related application also. So here this is one example, flow management related. See this WSN node. This node connected with one level sensor. Similarly, this second node is connected with the wall, and third one is connected with the laptop in this particular application. So connected with the laptop, there is master fancy node. That is like a wireless dongle only. Dongle is nothing but our sniffer. We will say sniffer only, or master node. So whatever the level, it is like a level information will be transmitted to the wall node and also copied to the fancy node. So based on the the sensor signal, the actuator will be performed through wireless. So if you want, you can connect more than one sensor in the field. Like more the number of maximum limit is available. So based on the turnaround time. So number of sensors can be connected here. Number of walls or actuators can be connected with the one node based on the field environment. In the case of automation. So completely, so whatever the information it is transmitting here for one valve is available here. Similarly, the information will be captured in the display node. So wherever the time constraint is okay, for example, like a fast varying process, we cannot use this delay application. For example, transmission and receiving will take time. Transmission and receiving will take some period. No, if you are able to tolerate that period, you can use. Even fast varying process we cannot use. Ordinary delay process, for example, temperature, etc., we can use, and PLCs can be used. I think you are able to understand. That's what it is available. Wherever time constraints are okay for transmitter and receiver, informations are okay to accommodate in a loop, then it's okay, perfectly all right. That's what. In this case, in a convention, I told no convention control. So the field to control loop, bunch of wires will be there, and control room to field, but back to field areas, no bunch of cables. Here it is wireless. We don't want bunch of cables from field to control room and back. That's what now we executed a lot of projects to customer field, other outside countries also. A lot of places they are executed from industrial automation team. That's what it is available. This is a test bench, not final version. The final version is different. That's with the modules, everything will be entirely different modules. Yeah. Coming to the next one, the healthcare management. This is also, but these are all our own design. This one is the wireless devices are our own design only. Even Bangalore division has PCB design, all the integration facilities. We will give the copy of blueprint. Completely, they will give the PCBs. Then next day, they will assemble from another sentence. Then finally, we have to test from who raised no, they will test the board. That's what it is available. Similarly, the third one, this is our own design, healthcare management related. This device is our own design. These are all from outside. This is procured from outside. See, this is nothing but healthcare related application. So test bench only. So SpO2 and beats per minute, not ECG and other data. Only SpO2 and beats per minute used in the testing. So SpO2 is nothing but the percentage of oxygen content in the particular person blood flow. And second one is beats per, that's a heartbeat related, generally heartbeat related. So these two information will be transmitted from this node to opposite node. Totally it is transmitting number of bytes, 256 bytes, but only 2 bytes are very important. We have to detect. The receiver end, it will receive all the information. Only 2 bytes will be detected and displayed in the display portion. The display portion completely like a JavaScripts and VB scripts. Both the options we developed. But we used both the cases, but JavaScript was really good for most of the cases for display and reliable support. But why do you want this type of cases? In a medical healthcare related, no, here it is 2 parameters, but a lot of other parameters are also available. So here we like even ICU unit. Sensors are connected to the patient. Then it is extended to the display unit through wires. In the wireless communication, sensors are connected to the patient. Then it is not extended to the display unit through wires wireless. Even we can move the patient to some other place in the same floor or different floors. Even still, he will be there at the data access. That's a facility or support available with at least in the WSN standard. Here we cannot use the streaming of like ECG related sync is required. So ECG and something image related not possible. Only the number of bytes possible with the WSN standards. And coming to the third one, this is also energy utilities also done some application in India also. See the condition, digital analog meters permission with some standards from the government also. Finally, we implemented with, for example, 3 houses are there, house 1, 2, 3. Each house energy meter is connected with a Zigbee node. Then first house energy meter transmitting second meter will transmit first and second meter to third one. Similarly, it reaches to the EBE database. If the distance between 1 meter to another meter is more than 100 meters, one router also required. So if a person didn't pay the bill for X month, the automatic server will open the base. That's a specialty, it is available. We verified with the digital analog all the meters. Basically digital, most of the places, it is like directly like easy to integrate. So coming to the next one, this is also TPMS related. So right side you can see ATL Lab Wipro Technologies. This is here one test bench. This is also test bench only. The TPMS, tire pressure monitoring and acceleration, nothing but in the high-end vehicles. Like one in between your rim to the tube tire, no, one small bend facilities will be there. Here it will fit small device, that is nowadays MEMS device only. So the 2 devices, 2 sensors are available. One is pressure sensor, to display the pressure safety related. Second one is acceleration sensor, that will measure the road condition, nothing but the road condition in the form of vibration. In turn, it adjusts the suspension of the vehicle. So these are all the supports that is available. This is also one. This is integrated with one electric vehicle. So we integrated with one electric vehicle with the ARM processor only. So the electric vehicle also even tests real device and lab device. That's what we recommended. Finally, we integrated with the one electric vehicle. The electric vehicle is nothing but this is the one cluster for electric vehicle. Nothing but not necessary to understand completely is analog cluster. This is digital. Right side is the digital cluster. It's completely touch screen panel related to cell phone. These are all analog clusters integrated with the electric vehicle. Then this is the actual hardware we used in the real electric vehicle for the electric vehicle drive and control, and also the TPMS information directly. So the ATL, you can see this is the ARM processor, our own design only. ATL, Wipro Technology. Even this one is available completely from our side. Even video also available. It will take more time. That's what I didn't collect the videos also. These are all the devices. See the condition, the process, same processor only. These are all driver, initial level driver support facilities. This is driver ICs. Then these are BLDC machines. Finally, you can fuse a program to this one. The wireless related additionally integrated with this particular CPU, the previous CPU. This CPU will do the complete control of BLDC machine, 6 lines of PWM from this machine, this hardware, plus wireless also, wireless for TPMS. That's what it is available. So final device we verified with the 3-wheeler, 2-wheeler, 3-wheeler, that is auto type, and trucks also. See, this type of motors will the capacity wise different, maybe for two-wheeler, three-wheeler, no, only changes this one. Battery also same. See, this battery basically 48 volt each slot. This is blue 1, 2, 3, 4, no, 12 volt into 4. 48 volt will be required. But see the IC, only the algorithm, hardware, everything same. Driver IC will be different and the will be different for two-wheeler, three-wheeler and trucks also. This driver, this green color and block sync is there, no? The complete board finally converted to this right side form. That is the real like driver in the box level, small box. Instead of engine, this driver box will be there. That's it. That's what. And wireless TPMS will be used for high-end vehicles, not in the ordinary vehicles. That's what it is available. Then coming to the exerta, suppose I don't want to do in the like real time, simulator and real time. This is one option. It is available in the maybe simulator. We have other option. NS2, NS3 options are available. Other wireless simulators are available. Exerta 2.1 is one. Another standard version is available. So here, see the condition: real device. And maybe one or two rival device, then router is the real device. Then from the router, you can connect to the simulator. This is PC. The round shape is PC or laptop. Similarly, it is coming out from the simulator laptop to out real devices. So the connection from router to the simulator portion is Ethernet or serial port. Similarly, from the simulator to this one is Ethernet or serial port. See, we can like connect real plus simulator. The simulator area, you can configure a big network or algorithms, routing algorithms, all these things. Finally, you can check the simulation analysis of real come your simulator. That's a like one special version is also available in the market, but commercial version. That's a like one additional facility, but you can use the NS2, NS3. That's more than enough. But you have to enter commands related facilities. You should know commands related. In this case, you should know programming also to some extent. So these are all the options it is available. Yeah, maybe you can see the condition. You can use different version of like different devices. Fancy instead of router 123 end device 123. Not only this. Like you can use other version like exercise like fancy router 1, 2, end device 1, 2, 3, etc., etc. That's what it is available. Maybe if you want additional support, any support is required, I'm also ready to support. You can contact my mail ID also. Whatever the support I can support from my end. Yeah, these are all the general references only. Finally, alliance supported information. Yeah. Thank you. Sir?
Sir, thank you, sir.
Sir, thank you. Thank you very much. Thank you very much
Sir,
to all.
Sir.
Yeah.
Kumar, sir, thank you, sir.
Thank you, sir. Thank you very much. Thank you very much to Sitaraman sir and Dhanalakshmi madam also. Thank you, sir. Thank you very much.
Yes, sir. Thank you, sir.
Fine, sir. I'm just closing from my end. Thank you, sir. Thank you very much to all. Yeah.
Thank you,
Bye.
sir.
Bye.
Thank you for your
Thank
informative
you.
session, sir.
Thank you, sir. Thank you very much. Thank you.
Participants kindly fill up the attendance form. It has been put in the chat box. Tomorrow the session starts by 10:15 a.m. We are using the same Google Meet link. Tomorrow first session is Influence of IoT in Industries 4.0 by Professor Dr. S. Murthy from NIT Trichy. Second session is on Internet of Medical Things by Dr. Varun Gopi from NIT Trichy. And the third session we have on cyber security by Dr. S.D. Sudarshan from CDAC Bengaluru. Participants are kindly requested to fill up the attendance form.